Hey everyone, I just finished diving deep into Microsoft's latest research papers and announcements, and I have to tell you, this might be the most significant moment in AI development since ChatGPT's release. What Microsoft has just accomplished fundamentally challenges everything we thought we knew about artificial intelligence development. They've just proven that raw computational power isn't everything. In fact, they've built a mathematical reasoning model that completely destroys competitors hundreds of times larger, and they did it in just 1 week using only 64 GPUs. But that's just the beginning of this story. Alongside this breakthrough, Microsoft has quietly rolled out 2 completely in-house AI models that could reshape entire industries. A voice AI that generates a full minute of natural-sounding audio in under a second, and their first foundation language model trained on 15,000 H100 GPUs, marking their independence from OpenAI and setting the stage for a completely new AI ecosystem. What we're witnessing here isn't just incremental improvement. This represents a fundamental shift in how we think about AI development, efficiency, and the future of human-computer interaction. So let's break down exactly what Microsoft has achieved and why it matters more than you might think. The mathematical breakthrough that changes everything. Let's start with what I consider the most groundbreaking development, R*2 Agent 2. Understand why this matters. We need to first acknowledge a fundamental problem that's been plaguing AI development for years. You've probably heard of chain of thought reasoning, the approach where large language models solve problems by stretching their reasoning out step by step, kind of like showing their work on a math problem. The theory sounds solid. If a model thinks longer and more carefully, it should catch its mistakes and arrive at the correct answer. But here's the reality that researchers have been grappling with. This approach has serious limitations. When a model takes a wrong turn early in its reasoning process, it typically doubles down on that mistake rather than correcting course. It's like watching someone confidently work through a complex calculation while making a fundamental error in the first step. No matter how carefully they show their work after that, the entire solution becomes worthless. Microsoft's research team looked at this problem and asked a different question entirely. Instead of pushing models to think longer within the same framework, what if we gave them the ability to interact with their environment, check their work dynamically, and adjust their approach based on real feedback? This is where R*2 Agent represents something genuinely revolutionary. Unlike traditional models that simply output text, this system uses genetic reinforcement learning to actively interact with a Python environment during its reasoning process. Think of it as giving the model access to a calculator, a coding sandbox, and a laboratory notebook, all rolled into one intelligent system. When R*2 encounters a mathematical problem, it doesn't just reason about it abstractly. It can pause, write actual code, execute that code, examine the results, and then decide whether it's on the right track. If the numbers don't add up or the logic doesn't hold, it adjusts its approach and tries again. This dynamic feedback loop makes it exponentially more reliable because it's not locked into a single reasoning path. But training a model like this presents massive technical challenges that go far beyond traditional language model development. We're talking about handling tens of thousands of concurrent tool calls during training, a computational nightmare that would bring most systems to their knees. Microsoft's engineering team had to solve some seriously complex infrastructure problems to make this work. They built a distributed code execution system capable of processing 45,000 concurrent tool calls with sub-second latency. Think about that for a moment. 45,000 separate code executions happening simultaneously, all feeding back into the training process in real time. They accomplished this by isolating code execution from the main training pipeline while maintaining high throughput through intelligent load balancing across CPU workers. Even more impressively, they developed a dynamic rollout system that monitors real-time GPU cache availability and distributes tasks based on actual system capacity rather than predetermined allocations. This means no GPU sits idle while others are overloaded, a level of optimization that's frankly remarkable. The end result? They trained this entire frontier-level model in just 1 week using 64 AMD MI300X GPUs. To put that in perspective, GPT-4 is rumored to have required thousands of GPUs training for months at an estimated cost of hundreds of millions of dollars. R-Star 2 likely cost a few $1 million total for training. That's not just an improvement, that's a complete paradigm shift in terms of efficiency and accessibility. But the real magic lies in the algorithm they developed. Group relative. Policy optimization with resampling on correct, or GRPO-RC. This is where things get really interesting from a technical standpoint. Traditional reinforcement learning rewards models for getting the right final answer, regardless of how messy or inefficient their reasoning process might be. This creates a problematic incentive structure where models learn to brute force their way to solutions rather than developing clean, logical reasoning patterns. GRPO-RC flips this entirely. Instead of just rewarding correct answers, it oversamples initial attempts, filters out noisy and error-prone reasoning traces, and puts much heavier weight on examples where the tool usage was efficient and the reasoning was clean and well-formatted. The model still sees failed attempts because learning from mistakes is crucial, but the positive reinforcement comes specifically from high-quality reasoning traces. Over time, this approach doesn't just make the model more accurate, it makes it more efficient and elegant in how it approaches problems. We're not just getting better answers, we're getting better thinking. The training strategy itself was remarkably deliberate and sophisticated. In the first stage, they didn't even allow the model to engage in complex reasoning. This phase was entirely focused on instruction following and properly formatting tool calls. They kept responses limited to 8,000 tokens, which forced the model to learn concise, effective strategies rather than developing bad habits around verbose, rambling responses. Even at this foundational stage, accuracy on mathematical benchmarks shot up from essentially 0 to over 70%. That's extraordinary progress for what amounts to basic instruction following. In Stage 2, they increased the token limit to 12,000, giving the model room to handle more sophisticated reasoning tasks. But here's where their approach gets really clever. In Stage 3, they filtered out all the problems the model could already solve and trained exclusively on the most challenging cases. This step-by-step progression meant the model was never allowed to get comfortable. It was constantly being pushed to refine and expand its capabilities. The results speak for themselves, and they're frankly staggering. On the AME24 benchmark, R-Star 2 agent achieved 80.6% accuracy. On AM25, it reached 69.8%. These numbers might not mean much in isolation, but here's the context that makes them extraordinary. This model outperformed DeepSeek R1, which has 671 billion parameters, nearly 10 times larger, and it accomplished this while using significantly fewer reasoning tokens, around 10,000 on average compared to over 17,000 for competing models. This isn't just about being better. It's about being dramatically more efficient while being better. What's perhaps most impressive is that even though R-Star 2 was trained exclusively on mathematical problems, it demonstrated strong transfer learning to scientific reasoning tasks and maintained solid performance on general alignment benchmarks. This suggests that the training methodology and agentic approach create a more adaptable form of intelligence rather than just memorized mathematical tricks. When researchers analyzed the model's internal workings, they discovered something genuinely novel. Beyond the typical forking tokens that encourage models to explore different solution paths, R-Star 2 developed what they call reflection tokens. These emerge specifically when the model is responding to tool feedback, analyzing Python output, evaluating results, and deciding what went wrong or what to try next. This is clear evidence of environment-driven reasoning rather than purely internal contemplation. The model is adapting its thinking based on external feedback from the real world, not just its own internal representations. This represents a fundamental shift away from traditional chain-of-thought reasoning and opens the door to AI systems that can reason in much richer, more interactive ways. The voice revolution. That's already here. While R-Star 2 represents a breakthrough in reasoning, Microsoft has simultaneously launched something that could transform how we interact with AI on a daily basis: MAI Voice 1. This speech generation model is built for speed, quality, and versatility in ways that existing solutions simply can't match. Here's the number that should grab your attention. MAI Voice 1 can generate 1 full minute of high-fidelity, natural-sounding audio in less than 1 second. And it accomplishes this using just a single GPU. Let me put that in context for you. Currently, if you want to create a 30-minute podcast episode with high-quality synthetic voice, you might need hours of processing time on existing systems, assuming you have access to powerful hardware. With MAI Voice 1, that entire 30-minute episode could be generated in 30 seconds. That's not just an improvement. That's a complete transformation of what's possible. I've tested most of the leading speech synthesis tools available today. 11 Labs produces excellent quality, but with significant generation times and premium pricing. OpenAI's voice models offer decent quality but limited customization options. Google's solutions are technically impressive but require complex integration and substantial infrastructure. MAI Voice 1 appears to solve all of these pain points simultaneously. The speed is unprecedented, the hardware requirements are minimal, and early samples suggest the quality is competitive with the best available options. What makes this particularly significant is its multilingual capabilities. Microsoft trained this model on a large, diverse multilingual dataset, which means it should perform well across different languages and cultural contexts. For global markets, this is crucial because most existing solutions are heavily optimized for English and perform poorly in other languages. Microsoft has already begun integrating MAI Voice 1 into their products. If you've used Copilot daily for news summaries, some of those voice updates are already powered by this model. In Copilot Labs, you can experiment with turning text into audio stories or guided narratives. But let's think about the broader implications. This technology could fundamentally disrupt several industries almost immediately. Content creators, podcasters, YouTubers, online educators could produce high-quality audio content without expensive studio setups or voice talent. The democratization effect could be enormous, allowing anyone with good ideas to create professional-sounding content. The education sector could be transformed. Online courses, language learning applications, and educational content could incorporate natural-sounding narration at a fraction of current costs. This could make high-quality educational content accessible in regions where professional voice talent is expensive or unavailable. Publishing could see a revolution in audiobook production. Publishers could convert written works into audiobooks at dramatically reduced costs, potentially making audiobook versions available for virtually every published work rather than just bestsellers. Customer service applications could deploy truly natural-sounding voice bots without the massive infrastructure requirements that currently make this prohibitively expensive for smaller companies. For accessibility, this represents a major advancement. Visually impaired users could have access to much higher quality audio versions of text content, while people with reading difficulties could benefit from natural-sounding text-to-speech across a much wider range of applications. However, we need to address the elephant in the room: the potential for misuse. With the ability to generate realistic audio this quickly and easily, we're inevitably going to see an increase in deepfake audio content. While Microsoft hasn't detailed the voice cloning capabilities of MAI Voice 1, the underlying technology certainly makes voice impersonation feasible. This raises serious questions about audio authentication, legal frameworks for synthetic media, and the impact on journalism and media verification. We need to start thinking about these challenges now, before they become widespread problems. Microsoft's Declaration of Independence, perhaps the most strategically significant announcement, is MAI1 Preview, Microsoft's first end-to-end in-house foundation language model. This represents a fundamental shift in Microsoft's AI strategy and could reshape the entire competitive landscape. Until now, Microsoft has primarily licensed or integrated models from external partners, most notably OpenAI's GPT family. Building their own foundation model from scratch represents an enormous strategic commitment. They've invested approximately 15,000 NVIDIA H100 GPUs in this project, a hardware investment alone that likely reaches hundreds of millions of dollars. But why would Microsoft choose to develop their own model when their partnership with OpenAI has been so successful? I believe there are several strategic factors driving this decision. First is control. Having a proprietary model means complete control over the development roadmap, feature priorities, and integration timeline. Microsoft no longer has to wait for OpenAI to develop capabilities they need or adapt to external priorities that might not align with their own strategic goals. Cost is another major factor. Licensing GPT models for Microsoft's entire ecosystem, spanning Office, Windows, Azure, Xbox, and countless other products, must represent an enormous ongoing expense. Developing their own model, while expensive up front, could be significantly cheaper in the long run. Differentiation becomes possible with proprietary technology. It's difficult to create sustainable competitive advantages when you're using the same underlying technology as your competitors. A proprietary model allows Microsoft to develop unique capabilities and user experiences that competitors can't easily replicate. There's also a geopolitical dimension that's increasingly important. In the context of US-China tensions and growing concerns about AI supply chains, having domestic-controlled AI capabilities is becoming a national security consideration. Self-reliance in critical technologies is increasingly viewed as essential. MAI1 Preview isn't designed to be the most powerful model available. Instead, it's optimized for instruction following and conversational tasks that represent the most common everyday use cases: writing emails, answering questions, summarizing content, helping with assignments, and providing general assistance. This focus on practical utility rather than benchmark supremacy is actually quite smart. These are the tasks that billions of people use AI for every day. Rather than chasing the highest possible scores on academic benchmarks, Microsoft is optimizing for real-world usefulness. Early indications suggest the performance is competitive. MAI1 Preview is already available on the LMSY's Arena platform, where it's being compared directly with other major models. From what I've observed, it performs particularly well on conversational tasks and practical applications. Microsoft is taking a measured approach to deployment, gradually rolling it out within Copilot, starting with text-based scenarios. They're collecting user feedback to refine the model before broader deployment, the approach that suggests they're treating this as a long-term strategic foundation rather than a flashy product launch. The real excitement comes when we consider potential integration across Microsoft's entire ecosystem. Imagine MAI1 deeply integrated into Office 365, providing native AI assistance in Word, Excel, and PowerPoint. Picture windows with OS-level AI capabilities powered by Microsoft's own model. Consider Azure Cloud Services with a proprietary AI backbone, or Xbox gaming experiences with advanced AI-powered NPCs. This integrated approach could create a more seamless and powerful user experience than any competitor can currently offer. Apple has their ecosystem advantage in hardware, but Microsoft could achieve something similar in AI-powered software experiences. The bigger picture, a new AI paradigm. When we step back and look at these three announcements together, a larger pattern emerges that I think represents a fundamental shift in AI development philosophy. R*2. Agent demonstrates that smarter training methods can overcome raw computational scale. MAI Voice 1 shows that specialized models can achieve extraordinary efficiency for specific tasks. MAI1 Preview represents a move toward vertical integration and ecosystem control. Together, these point toward what I'm calling the efficiency overscale paradigm. Instead of just building bigger and bigger models, the industry is shifting toward more intelligent training approaches, more efficient architectures, and more strategic deployment. This shift has profound implications for the competitive landscape. OpenAI, which has built its strategy around having the most powerful general-purpose models, suddenly faces a partner-turned-competitor with a very different approach. Google needs to accelerate Bard and Gemini development while finding new ways to differentiate. Anthropic must expand enterprise adoption before Microsoft's ecosystem becomes too dominant. For smaller AI companies and startups, the landscape becomes more challenging but also more diverse. More platform options mean more opportunities but also more complexity in terms of vendor relationships and avoiding lock-in risks. From a geopolitical perspective, Microsoft's move toward AI self-sufficiency is significant. In the context of ongoing US-China competition in AI, having strong domestic capabilities becomes increasingly important for national competitiveness and security. Looking forward, timeline, and impact. So when will regular users actually see the benefits of these advances? R*2. Agent capabilities could start appearing in coding assistants, educational tools, and mathematical applications within 6 to 12 months. The infrastructure is already proven, so it's really a matter of integration and user interface development. MAI Voice 1 is already available in Copilot labs for experimentation, and I expect broader deployment throughout 2025. The technology is mature, and the use cases are clear, so adoption should be relatively rapid. MAI1 Preview is seeing gradual rollout in Copilot now, but full integration across Microsoft's ecosystem will likely take 1 to 2 years. This is a massive undertaking that touches virtually every Microsoft product. One crucial question is whether these efficiency improvements will translate to lower costs for consumers. Theoretically, more efficient models should enable lower pricing, but whether Microsoft passes those savings to customers or retains them for improved margins remains to be seen. Competitive pressure will likely force at least some cost reductions, particularly in the near term. The bottom line: what Microsoft has accomplished here goes beyond incremental improvement. These aren't just better versions of existing technologies. They represent new approaches that could fundamentally change how AI systems are developed, deployed, and integrated into our daily lives. R*2. Agent proves that intelligent training can beat brute force scale. MAI Voice 1 democratizes high-quality speech synthesis. MAI1 Preview marks Microsoft's evolution into a fully integrated AI platform company. The combination of these three elements could create the most powerful and integrated AI platform available today. Microsoft now has advanced reasoning capabilities, state-of-the-art speech synthesis, and their own foundation model, all optimized to work together within their massive software ecosystem. However, success will depend entirely on execution. Microsoft has a mixed track record with consumer-facing products, and there's a significant difference between impressive research demonstrations and products that genuinely improve people's lives. But regardless of the specific outcomes, one thing is certain: the AI landscape just became significantly more competitive and interesting. Microsoft has positioned itself as a true independent player in AI development, not just a distributor of other companies' technologies. The question now is whether they can deliver on these promises and create experiences that are genuinely better for users. Given what they've accomplished in just the past few months, I'm more optimistic about that possibility than I've been in quite some time. What we're witnessing might be the beginning of a new era in AI, one where efficiency, integration, and practical utility matter more than raw scale and benchmark scores. And if that's the case, Microsoft might have just positioned themselves perfectly for that future. The AI revolution is far from over. In fact, it might just be getting started.